Okay, so we're looking at bivariate data. So everything else we looked at before was univariate data. So what univariate data was one variable. One variable. What sort of graph did we do for univariate data? Histograms. So one variable data, histograms. For bivariate data, we have two variables. And what sort of graph, does anyone know what sort of graph we do for these? Got two variables? Good, a scatter plot. Okay, so the graph we use is a scatter plot. And what we're looking at is two different things and whether there's a relationship between them. And so we need to know how to describe these relationships. Before we even do anything about the actual data, you need to be able to see what a scatter plot looks like and be able to describe some of the relationships between them. So, for example, you've got a strong, a moderate, and a weak relationship. Okay, there's a couple of different types of relationships we've got here. So, actually, we'll start with different. Okay, we've got, how do you think you could describe, not strong, moderate, weak, how do you think you could describe that data compared to this data? Any idea for a word for this, for the dots here? It is positive. We'll talk about that in a second. Positive, what sort of relationship for one on the left? Linear, okay? So you've got linear and you've got non-linear. So in a test, you might be given some dot plots and you have to describe them. So the first thing you want to say is it linear or is it not linear? Okay, we don't need to know if it's quadratic or any other sort of relationship. We just want to know linear or not linear, okay? Then we've also got, we just said positive or negative. So if it is linear, if linear, we've got positive, which looks like that, or we've got a negative linear relationship. Okay, so there's three things you're going to look at. You're going to look at linear or not linear. You're going to look at positive or negative. So you need to know those directions, but you should know them already from our linear relations. And then we want to know about the strength of the relationship. For strength, there's three types. We've got weak, moderate, and strong. So, a strong linear relationship might look something like this. Okay, you can definitely see that it's going in a straight line. They're pretty close together. A moderate linear relationship is a bit more spread out, but you can still see that they're heading in a particular direction. Okay, you can still see that those points are heading in a positive linear direction. A weak relationship's even more spread out. But you should still be able to see some sort of direction happening. You can also have like no relationship where they're really, really spread out, but usually weak's a bit more used, more often used. So, if you get given a scatter plot like this, you want to talk about the relationship between the two variables, whether it's linear, whether it's positive or negative, and whether it's weak, moderate, or strong. Right? This is called, in terms of linear relationships, this is called the correlation, right? Correlation between two variables. The correlation has something called a correlation coefficient. and it's labelled with an R. Now the correlation coefficient is a number which tells us the strength of the relationship between the two variables. It has a number range from -1 to 0 to 1. Okay, 1, if you had a correlation coefficient of 1, it means it has a perfect positive linear relationship. What do you reckon it means by perfect positive linear relationship? Perfect. Yeah? It's not specifically a number, but if you did that, they would be in a straight line, right? So it means that the points are in an exact straight line. There's no deviation from that straight line. Perfect positive linear relationship. As you move into these decimals, these are all positive, and it goes from weak to moderate to strong to perfect. Sorry. So 0.2, for example, would be a weak positive relationship, 0.5 moderate, 0.8 strong, and a 1 is perfect. What do you think -1 represents? Yep. Perfect. It's a perfect negative linear relationship. So once again, straight line, but it's going in a negative direction. And this time, once again, -0.2 would be a weak negative relationship. -0.5, moderate. -0.8, strong, negative linear relationship. So correlation is about what the relationship is between these two things. In your calculator, when we do this in your calculator in ClassPad, it actually gives you a number. So it actually gives you R equals and a number. And so you can compare different scatter plots and say which one has a stronger relationship just from that number. So that number is really important. So R, correlation coefficient, tells you the strength of the relationship between two things. Are there any questions to there? All right, so we have these scatter plots. We have to actually know how to draw a scatter plot, all right? And when I talk about two variables, you also need to understand what that means. So we don't have any frequency anymore. There's no frequency in bivariate data. Bivariate data is looking at like someone's math score versus someone's science score. Okay, so we'll just do an example with this and then we'll try and draw a scatter plot from it. So if we look at maths, science, and we draw this table, and we'll just look at like six students, right? And we say they both did a test, and we go, okay, this person got 38% for maths and got 50 for science, 52, 53, 52, 71, 83, 75, 60, 71, and 73, 80. So this is a set of scores. There are two variables, there's maths and there's science, right? Now, you have to pick which one is going to be your x and which one's going to be your y-axis, okay? So your top one is we usually say is your x, and your bottom one is your y, right? Your x-axis is also called, in science, it's called a certain sort of variable. Can anyone remember what sort of the words we use for variables in science? Independent, okay? So x-axis is your independent variable. And your y-axis is we're looking at what changes because of it, okay? But in maths like this, we're not talking about it causing it. So we're not going to say, oh, there's a really strong relationship between your maths and your science marks. Your maths score causes your science score to be better. Okay, we never say that. It's always about the relationship. So you just say there's a strong relationship between them. But we never say they cause each other, right? Okay, has everyone got that data down? Okay, so if we look at this graph, I'm sorry you don't have any graph paper. We want to go, okay, X, Y, maths, science. Now, the scores do go from 0 to 100, but where do I really need to start with the maths? 38 at least, okay? So I'm going to go, okay, I'm going to break the scale. I'm going to start at 30, 40, 50, 60, 90. And for science, our lowest score is 50. So again, I can break the scale and start it at 50. That's fine. You just can't break the scale in the middle. So I can't go like, you know, that 38. I couldn't go up to 38 and then break it and then start again. Okay, you can only break it at the start. So we go 50, 60, 70, 80. And we try and have a title if we can, so maths versus science. All right, scatter plots. There's two ways of doing your points. You can either do a little cross, make sure that where the two lines cross over is exactly where your point is, or you can do a little dot, okay? What we don't want is a massive cross or a massive dot, okay? So a small dot or a small cross. It's up to you. I usually use dots, all right? So 38, we go across to 38 for maths and up to 50 for science, and we draw a dot. Usually in a test, what happens is we give you about half of this data and we just get you to plot maybe 3 points just to know that you can plot them. I then go 52 and 53. You don't have to label the dots, it's just a dot, okay? 52 and 71. $83 and $75. $60 and $71. And $73 and $80. What sort of relationship do you think these dots have? Moderate what? Positive, linear. Okay, so that's what if you were asked about the relationship, you'd say moderate, positive, linear. Any questions about how to do a scatter plot? Okay, we then get asked to do some other questions. So that's worth like 3 marks. All of these questions are worth between 8 and 10 marks. There'll only ever be one on your test and one in your exam, but it's worth 8 to 10 marks, just one question. All right? So what we then need to be able to do is see what sort of relationship this is. And what we do for this is we draw a line of best fit. There's a few different names for this, all right? So I'll just move down. Okay, we need to draw a line of best fit. Yeah. I'm on recording, so just be aware. You need to interrupt my class right now to do that. Get me a pen, quick. Okay, so draw a line of best fit. It's also called a linear regression line. And you need to know the word linear regression because in your calculator, that's what it's called. Don't interrupt my class again. I draw a linear regression line. Okay. In your syllabus, it says you must draw a linear regression line by eye, okay? Which means in your test, we're never going to ask you to specifically use your calculator for this. It goes on what you're doing. So, what you need to have is a ruler. And what we're trying to do is we're trying to draw a line which goes as close to all the points as possible. So we're drawing a straight line. Which goes as close to all points as possible. With a similar number of points on each side of the line. If you're in a calculator section, you want to find the mean of each of the scores, and actually you can sort of almost rotate your ruler around that point. So if you're not in a calculator section, then you can't do that. So in this table here, sorry, I'll just make this a bit smaller so you can see everything. Is that all right? So in this table here, we can go, let's find the mean here. So 38 plus 52 plus 52 plus 83 plus 60 plus 73, all divided by 6 equals 59.6 recurring. And same for the other. $66.6 recurring. Okay, if I put in that point, it's not a specific point, but it's a really good rotational point. So I go, okay, 59.6, 66, so I go around here. Now when I put my ruler up, I've now got a point where I can actually sort of rotate and pivot around that point. If you don't have a point to pivot around, your ruler sort of ends up moving all the way around and you don't know where to put it. So we look and try and find a line which goes through that point and has as many similar amounts on both sides. Now, this isn't perfect on here, but something like that. Now, yours might be a little bit different. You want to make sure your line goes all the way through the whole graph and it has similar numbers of points on either side. So I think that's pretty close. If I could, I would almost make it a little bit lower. Julian? Yes. So just the one at just the one on the end. Okay, so what we do is we try and look for, we find that mean point, and it needs to be close to that, and it needs to be similar, but it's always going to be a follow-through mark thing. So once you've done your line, everything after your line is a follow-through marks. So even if you completely stuff up your line and put it somewhere completely wrong, you might lose 1 mark for your line, but then you've got 4 or 5 marks still to go for the rest, which is all follow through. So because in the syllabus it says line of regression by eye, we always have to give you follow through marks list depending on what you do as your line. But are there any questions about the actual line? So it needs to go through the whole graph and it needs to be as close to all the points as possible. All right? This line is what we can now make predictions on. Because I can't say make a prediction for if someone got 52 in maths. Why do you think, if I didn't have that line, why do you think I couldn't make a prediction to say what are they going to get in science if they got 52 in maths? Yeah. It could be anywhere. And also why, specifically with our points here, 52 in maths. We've got 2 points there which have 52 in maths with 2 very different scores, don't we? So I can't say, oh, if you get 52 in maths, you're going to get 53 in science. Because someone else who got 52 in maths got 71 in science. All right? So we're looking at all of the data together and we make this line from it, and that's where we make predictions from. So this line is really, really important, okay? So we make predictions from our line of best fit. Sorry guys, I'm going to need to add in one more word. Line of best fit, linear regression line, and also least squares regression line is also sometimes used. Least squares regression line. Anytime you see regression line, it means line of best fit, okay? But sometimes that comes up as well. Okay, so we can make predictions from our graph. You need to show that you're making predictions. So the next question in this test, so first couple of marks would be plot points in a scatter plot. Fourth mark would be draw a line of best fit. So that's 4 marks done. Okay, we've then got another 4 or so marks to go, and the first 2 are going to be about predictions. All right, so we're going to go, okay, from your line of best fit, predict the science mark if they received the following in maths. Okay, and it might say, let's say 52% in maths, and then let's say 90% in maths. 52 and 90. Below the page just says 52 and 90, okay? So we need to be able to look at this and go, okay, how do I make a prediction? I go 52 at maths, and you need to use a ruler and actually sort of show what you're doing. If you can show me what you're doing, I can give you follow-through marks easier. Okay, so 52 at maths, where does it hit the line? It hits the line at 61. Can everybody see that? So we use our line to make predictions. So, okay, 61, that's a mark. Pretty easy marks here, guys. 61 in science. Yours might be different, so write down whatever you got because your line of regression is going to be a bit different. As I said, we give you follow-through marks. We need to show us how you got that. So that's where the dotted lines come in. You need to show me how you got the answer you got. Okay, then 90 is up here. So we'd say, okay, 88. So if you've got 90 in maths, we'd assume that is probably going to get around the 88 mark. And yours might be a little bit different. This is going to be a bit longer note session today, guys, but tomorrow we're just going to quickly look at calculators to this, and we're just going to do all of this today, okay? Sorry, on Wednesday, I mean. All right. So that's 2 more marks. So we've got 6 marks out of 8 so far. Are there any questions about how you get those 6 marks? Plot the points, draw the line, make some predictions. The last thing you get asked about is about the accuracy or the confidence you have in your predictions, okay? So how confident are you in these predictions? So how confident would you be in saying, yeah, I reckon that person probably would get 61% if you got 52? How confident are you? What things do you think might impact on how confident you are? So again? The accuracy of the graph. What else? We talked about right at the start. We talked about some things, Chris. Good. Okay. So the data we have, which is exactly what we're going to talk about in a second. The data we have, you're more confident in that. We know that those people got those scores. We don't know that anyone's actually got 90 in the maths test. Is it possible? We don't know if you can get 90 in the science test. So that prediction is less reliable, the 91, than the 52 one. What else could impact on our confidence in this? We talked about at the start of the lesson. The strength of the graph. So if you've got a perfect relationship, then you're more likely to have more confidence in your data, okay, compared to a really weak relationship. So those 2 things we can talk about, all right? But the main one, as Chris said, was the fact that it's in the data, okay? So there's these 2 words you need to know about. And the question you'd get asked is, how reliable are your predictions? And you need to use 2 words. Can anyone remember what they are? Interpolation and extrapolation. These questions are usually worth 2 marks. They're usually worth a mark for you saying, yeah, it's reliable, and then 1 mark for you saying because it's interpolation. It's not reliable because it's extrapolation. So interpolation means your prediction is within the given data set. It is more reliable than if it's outside. It's more reliable. Extrapolation means your prediction is outside the given data set. It is less reliable. Okay? You have to use the word interpolation and extrapolation in these questions or you will not get the marks. Just lastly, the strength of the correlation will also impact. So strong relationship, more reliable predictions. However, if you talk about the strength and you don't talk about interpolation interpolation or extrapolation, you're not going to get the marks. Okay, so it's something that you can add to it. Excuse me. All right, so just quickly, let's let you finish that. If we go back to our graph, we need to know where's interpolation and where's extrapolation. That's the important bit, all right? So we're really looking at that line. I'll come back to this if that's okay, guys. I just want to go through it quickly. So I'll go back to that at the end. So we're almost finished, all right? So interpolation is just below the bottom point we have information and just above the top point we have information. So inside there is interpolation. We have data which shows that some of those scores are possible. We know those relationships close to there. It's interpolation. Anything within there is a stronger relationship. Okay, or not a strong relationship. It's more reliable data. Okay, it's a more reliable prediction. Anything outside of that, up here, extrapolation. And also down here as well. Okay, so extrapolation is the bottom part of the graph where you don't have any data and the top part of the graph where you don't have any data. Interpolation is in the middle where you've got data, where you've actually seen that it's possible. Can everybody understand that? Oliver, you want to go get a drink? Everyone okay with that? Okay, so last bit of the question. It says we need to say about their reliability. So it'd say 61% is reliable because, why? It's interpolation. 90% is less reliable because it's extrapolation. And that's your 8 to 10 marks. Done.